Welcome to the SOS video on systems of linear inequalities. Systems are two or more either equations or inequalities and that are graphed on the same coordinate plane. So today we're going to use your skills in graphing a linear inequality. When you're asked to solve a linear inequality system, you need to find the shaded region that contains all the ordered pairs that make both inequalities true. So how do you graph a system of inequalities? First thing you do is graph the first inequality. Make sure to show the method you use to graph the boundary line. So that's either a table of values or most people will use slope y-intercept method. So you need to write slope equals and y-intercept equals to show how you graphed it. Then label the shaded region with the inequality. Second step, graph the second inequality on the same coordinate plane using these above steps. Third, write a letter, usually S, to show a solution set in the shaded region that shows the intersection of both graphs. And finally, you want to check by substituting an ordered pair from the intersecting regions. Make sure it works for both inequalities. And if you recall with your calculator how to enter an inequality. If I have this inequality, I would type it in y equals. Then you move your cursor, the arrow, to the far left side of y sub 1. You're going to press enter. And then you're going to see a choice of the color that you want, as well as the symbol. Go down to the symbol and press your right arrow until you see this one displayed, because this is greater than or equal to. If you need to, you can press zoom number 6 for a 10 by 10 window, and then press graph to see your graph. Remember, the calculator displays a solid line at all times. You have to decide if your graph has a solid or dashed line. And it has a dashed line when it either has a less than or a greater than, when there's not an equal sign underneath it. Okay, let's take a look at the first question. You're being asked, are these points part of the solution set of the graph to the right? So one of the easier ways to do this is actually plot those points and see, does it fall into the intersecting region? So -2, -3 is here, and that definitely is outside this intersecting region, so it is not a part of the solution set. -4, 0 is over here. It looks like it's part of this, but remember, it's right on a boundary line, and this boundary line happens to be dashed, which means no point on this boundary line can be included. So this also is not part of the solution set. Now we have 0, 1, and this is on the boundary line that has this intersecting region, so this is included in the solution set. And finally 3, 1. And this is not anywhere in the solution set in this intersecting region, so this is not part of the solution set. Okay, let's take a look at how we're going to graph the following systems of inequalities. When we're finished and we have an intersecting region, we're going to mark that with a capital A for answer. Okay, let's take a look at this first one. This is already set to graph because y is isolated. So I'm going to show the method I use to graph. My slope is 4. Since I need to go in 2 different directions, I'm going to make that a fraction over 1. My y-intercept is -5. So I go to my graph, make sure that you label your axes, and I'm going to draw my boundary line. I'm writing a reminder to myself that the boundary line is dashed, because this does not have an equal sign underneath the inequality symbol. So I'm going to plot the points using this information. I start at my y-intercept of -5, and this is change in y over change in x. So change in y If it's positive, I'm going to go up. Change in x in the bottom. If that's positive, I go to the right. So up 4, to the right 1, put a dot. Up 4, 1, 2, 3, 4, to the right 1, put a dot. And let's do one more. Okay. You're going to take your straight edge and you're going to make a boundary line that's dashed. So what that means is every so often, lift your pencil from the paper to show that this is a dashed line. Now, the very important part, which part gets shaded? Remember, a boundary line splits a coordinate plane into two regions. We don't say it splits in half because this plane continues forever. These arrows means it goes on forever. But this does split it in two regions. One region has all the correct solutions. One region has no correct solutions. So we have three ways of checking to see which is the correct shaded part. One is, I have my hiker, starts over here, and if it's greater than, I'm going to shade everything above the hiker. If it's less than, I shade everything below the hiker. This is less than, so I go to my boundary line, and I'm going to shade everything below that. Start at the boundary line, have this in a slant, and only show about 6 lines that cover this fully. You'll see why in a moment, why you don't want to be coloring this in or using more lines. Another way to check to see if it's a shaded region is pick a point called a test point, and we're going to see if it works in your original inequality. So I'm going to pick 1, 2, 3, 4, 1, 2. This is my testing point. You don't want to pick a point that's on the boundary line. You like to pick a point that's in the region. Since this is where I think it should be shaded, I'm expecting my testing point to work in the inequality. So let's see. My testing point is 4, 2. Here's my original inequality. I'm going to substitute 2 for y, 4 for x, and then I calculate and see if this is correct. Is 2 less than 16 minus 5? Is 2 less than 11? It is, which means I know my testing point is correct, which means I know this was shaded correctly. And the last way you can check is to put this in your calculator. Y is less than 4x minus 5. You're going to go to y equals 4x minus 5, and then move your cursor to the left of y, press enter, and then go down to where the symbols are and make sure that you are having this symbol. Which tells the calculator it's shading below. And when you press graph, you'll see that it matches here. I also need to write this in my shaded region. I'm going to put this up here. Y is less than 4x minus 5. Okay, I graphed one linear inequality. Now we're going to graph another one. This is y is greater than or equal to negative 2/3 x plus 8. It's ready to be graphed because y is isolated. This is going to be a solid line, so I'll write a reminder to myself. My boundary line is solid because I have that line underneath. And my slope is negative 2 over 3. You could also write 2 over negative 3. It's your choice. And your y-intercept is 8. Okay, so let's graph this one. If my slope is negative 2 over 3, this is change in y. So this is either going to go up or down. Since it's negative, this is going to move down. This is change in x. I either go left or right. Since this is positive, I go to the right. If you chose to write it as 2 over negative 3, well, the change in y on top, if it's positive, that's going to go up. The negative 3 on the bottom, I'm going to go to the left. And I'll show you on here, it did not matter which one of those you picked. So let's start with 8. 1, 2, 3, 4, 5, 6, 7, 8. And I can go down 2 and 3 to the right and put a dot. Down 2, 3 to the right and put a dot. Down 2, 3 to the right and put a dot. If you had decided to go this way, starting at the y-intercept, you could have gone up 2 and 3 to the left. And you notice that will still be in the same line with the other points. Okay, so take your straight edge. We're going to go to those points. Remember, since there was an equal sign underneath that inequality, this is going to be a solid line. So you extend that, and you put arrows at the end. Now let's take a look at how we should shade it. So if it's greater than, here's my hiker. If it's greater than, we're going to shade above that hiker. So it will be shaded like so. And it's helpful if you use colored pencils to really make it stand out, so you can see where the regions intersect. Okay, before I write the solution set with the capital A, I'm going to pick a testing point here. And actually, you can pick a testing point anywhere. So I could say, you know what, I'm going to pick 0, 0. That's going to be my testing point. And because it's not in this shaded part, I do not expect it to work. So let's see what happens. I'm going to go to my inequality that I started with. In place of y, I put 0. In place of x, I put 0. And let's see what happens. Is it true that 0 is greater than or equal to, well, this is 0 plus 8, greater than or equal to 8? That is not true, which means this testing point did not work, so this area should not be shaded, which is exactly what we thought. The third way you can check the shaded region is put this into your calculator, y equals, move to the left of y, press enter, go down to where the symbols are, and since this is greater than, your calculator is looking for this symbol to say that you shaded above. And once you pick that, press OK, press graph, and you'll see your graph looks exactly like this. I'm going to write my inequality in the shaded region. And I'm going to mark the solution area with a capital A. So I look where this shaded part intersects with this shaded part. Okay, and the capital A finds a different color. The capital A is right here. This is my shaded region, my intersecting region for both. What you can also do is pick a point here to make sure it works for both of these. I'm going to pick this testing point. This is 8, 6, and I'm going to make sure it works for both of these. So I have 8, 6 as my testing point for the system. Does it work in y is less than 4x minus 5? Is it true that 6 is less than 4 times 8 minus 5? 6 is less than 32 minus 5, 27. That's definitely true. Remember, it also has to work in the other inequality. So my other inequality was y is greater than or equal to negative 2/3 x plus 8. Is it true that 6 is greater than or equal to negative 2/3 times 8 plus 8? 6 is greater than or equal to, well, negative 2/3 times 8, let's see, that's negative 16 over 3, negative 5 1/3. And when I add 8, that ends up being 2 2/3. And is 6 greater than or equal to 2 2/3? Yes, it is. So you know for sure that worked. Another way you could do that is make sure that you graph both of these in your calculator and look to see where those regions intersect. So this has been an SOS video on how to graph systems of linear inequalities.